So let's look at how we implement the add for the linked list based for sorted list. We pass the element in. We rely on previous location and location to travel through the list. We have the list elements. So location we point to equals to the list in the beginning, right? Before we do iterations, just like this image. In the beginning we have list, location point to this, and we travel until we find a location to add. We want to add count, right? So previous location equals to null. Alright, in the case that we just discussed earlier, right, if it's equals to null, one case is when it's empty, like this image. It's just insert at that point. And another case is if it's happened to the first one on the node, right? Like in the image here. If it's the first one on the node, previous location equals to null. Then we have to set the code to look like new node, right? And set new node link to location. I'm sorry, set new node links to list, and then list equals to new node. Like this is new node. Set new node list to link to list, like that, and then move list to new node, right? So that's one scenario. The second scenario is this one, right? When it is in between. That means we do else. Else case, that means it's insert in between. In between, that means new node does set links to the location. So new node set link to location. And then we have to change the link of the previous. Previous dot set link to new node. Previous dot set link to new node. And then we increment, right? Now this is just the logic to find the location. Alright, first we initialize, we need two pointers, previous location to null and location to list. Then we just iterate as long as location not equals to null. If it's equal to that at the end of the list, we keep iterating by getting in 4 and do compare to. If it's less than 0, then we just move the previous location to the location, and location equals to location get link until it's done, right? Else that means we find a location and we break out, just like the way we did in array. So that's how we add with reference based. Alright, so now this is just about if you want to read and write to the binary files. So the class must be serializable. Like they talk about save the song, and this is song is a class that we want to write to the file, right? So if it's text file, you don't need to serializable, but if it is the binary file, we need to do serialization. And we just use write object, object output stream, read object, object input stream. For the file, we can just use file reader for the text file and use scanner to read in the file. But for the object, we have to rely on the object output stream when you write a file, and file output stream and pass the file name. And to read in, we rely on object input stream and file input stream. But the write and read object must be serializable. Like for example, let's look at the code here. So this is a song. Song has to be implement serializable. Now why we want to talk about this? Because The disk structure, after you create a list, you need to store it, right? Just like we mentioned in our application, user store into the list, and we have to write a list to the file as the binary file here, right? So like user.dat, right? Now this means user's class must be serializable, implement serializable. Then you can, when you do write output stream, we talk about this, we can do user file output stream right to data. That what mentioned in the slides. Exactly the same. Object input stream, then you can read it. Alright, so, and that's pretty much it for chapter 6. And this is just showing application with a song. I'll be writing application for our create user account. Alrighty, so